In the world, matter cannot exist without form, nor form without matter. These two things have an indissoluble unity between them.
Parmenides, who said that change is an illusion, permanence is reality.
For Aristotle, both matter and form are eternal. Generation, that is to say becoming, is always in a state of reproduction in which matter generates matter and form generates form. A transition from possibility to reality suggests motion. The motion that is the being of the world is self-existent and eternally dynamic.
The harmony of the natural world is based on four great forces. Hawking himself informs us about these forces.
In the early 60s, the forces that were known to physics were classified into four categories that seemed to be separate and independent of each other. The first of the four categories was the gravitational force, which is carried by a particle of spin 2, called the graviton. Gravity is by far the weakest of the four forces. However, it makes up for its low strength by having two important properties. The first is that it is universal. That is, it affects every particle in the universe in the same way. All bodies are attracted to each other. None are unaffected or repelled by gravity. The second important property of the gravitational force is that it can operate over long distances. Together, these two properties mean that the gravitational forces between the particles in a large body all add up and can dominate over all other forces. Gravity will cause a sufficiently large body to collapse in on itself, and nothing can stop it. In the case of an isolated body, like a star or a galaxy, the collapse will produce a black hole. The second of the four categories into which the forces were divided is the electromagnetic force, which is carried by a particle of spin 1, called the photon. Electromagnetism is a million billion times more powerful than the gravitational force. Unlike gravity, it can act over great distances. However, unlike gravity, it does not act on all particles in the same way. Some particles are attracted, some are unaffected, and some are repelled. The attractions and repulsions between the particles in two large bodies will cancel each out almost exactly, unlike the gravitational forces between the particles, which will all be attractive. That is why one falls towards the Earth, and not towards a television set. On the other hand, on the scale of molecules and atoms, with only a relatively small number of particles, electromagnetic forces dominate gravitational forces utterly. On the even smaller scale of the nucleus of an atom, a trillionth of a centimeter, the third and fourth categories, the weak and strong nuclear forces, dominate other forces.
The four great forces, of which Professor Hawking spoke, determine the measure of function of universal harmony. Both the quality and the quantity of each force yield a total result exactly such as the universe needs in order to exist. If just one of these four forces was a little weaker, or a little stronger than it is, then these four forces could not coexist in a harmonious whole. And, to be sure, with that loss of measure, the universe would be destroyed. That measure of complete harmony has a divine source.
Θα ξεκινήσω απευθείας από εσάς, κύριε Παπά.
In my television program, Apocryphal Harmony, in a broadcast dedicated to the whole of the cosmos, I discussed with my guests whether it was possible for man to comprehend the totality of the world that we are able to perceive outside us, beyond the Earth, beyond the planetary and galactic system. That entire known universe, which we detect at night with telescopes, constitutes a substantiated part of a whole that is perceptually unsubstantiated, since it is impossible for us to comprehend that whole. Whatever man knows, and whatever he will know in the future about the universe, will always be scant, given conventional human development. Whatever we cannot see, whatever we cannot measure, we must consider as non-existent, in the sense that it is non-being as to our apprehension of it. And whatever is non-being does not move, since it does not exist in our minds. Motion is a property whose limits are within human calculation. Whatever we perceive as existent, we can say with certainty about it that it moves and is real. The water that flows from the cliff and fills the lake is a reality. But the systems of the galaxies, beyond the borders of human perception and measurement, are not real. Hence, they do not have movement, since we only suppose that they probably are found in distant worlds.
The whole of the universe is not calculable with precision, nor measurable, nor demonstrable. It is beyond reason, for it has unknown limits. And finally, it is beyond all human computation or speculation.
Therefore, the whole is immobile and conceptually belongs to the realms of ideas concerning God. Every scientific theory that tries to prove that the existing knowledge of the part constitutes the scale of interpretation of the whole brings to my mind the fisherman who desperately tries to illuminate the ocean with a lamp on his boat. The whole, even as a word, is conventional. Nothing bars us from saying that the whole can reproduce itself in a framework of infinite arithmetical mirror images of wholes. Have you ever entered an elevator that has mirrors all around? If not, imagine yourself as a conventional whole. Go into an elevator with mirrors and count, or try to count, how many times you see yourself all round. Many times? Very many? Or an infinite number? Our attempt to understand the universe in its wholeness indicates that our minds try to create a unified theory in which the totality of laws of the universe will be known, even if only conventionally, and we will be able to interpret it. Hawking himself discusses the theory of everything.
On April the 29th, 1980, I gave my inaugural lecture as the Location Professor of Mathematics at Cambridge. My title was, Is the End in Sight for Theoretical Physics? I described the progress we had already made in the last 100 years in understanding the universe, and asked what the chances were that we would find a complete unified theory of everything by the end of the century. Well, the end of the century is almost here. Although we have come a long way, particularly in the last 3 years, it doesn't look as if we are going to quite make it. But this seems an appropriate time to review the progress we have made, and ask what the prospects are that we attain the goal of theoretical physics in the not-too-distant future. Or will it always be just over the horizon?